back to my channel. Today we're going to do the CIE A level further math past paper on 2020, the May to June series on paper 4.1, question number 3. The continuous random variable x has the PDF given here. And in part A, you're asked to find the EX. So you may refer to your textbook or your notes how to find EX. We can actually do integration of x times fx. So here we can write it as EX equals to integration 0 to 1 x. For our fx, we have here 3/16 times 2 minus square root of x. So for our constant part, 3/16, we can write it here, and then we can left our bracket inside here. And then we plus the other parts, we have 1 to 9, and then x. For our fx, we have 3/16 times square root of x. Again, we can put our constant parts out there and leave it the x here. And we can do some simplification to make it look easier. So this time we can multiply it to x minus x. We have 1 plus 0.5, which is 1.5 dx plus 3/16. Again, we have x, and then this time we have 1 minus 0.5, so we have 0.5 as our index, dx. So we can do the integration now. We have 2 and then x squared over 2 minus x. This time we have our index as 2.5, and then 0 to 1 plus 3/16. This time we have 0.5 plus 1, so we have 1.5, and then 1 to 9. Okay, so make it look more clear and simple. We can have 2/5 here, and then just the same as here we have 2/3, and then we can substitute our 1 and 0 into the bracket. So now we have 1 minus 2/5 times 1 minus 0 plus 0. So we can just make it look clear. And here we have 2/3, 9, and the index is 1.5 minus again 2/3, and then 1 here. And the last step, we can simply use our calculator to find out the exact value. This time we have 269 over 80. And this is the solutions of part A. For part B, we have a new random variable y, such that y is equals to square root of x. So every time, make sure that you can change it back to x equals to something. This time we have x equals to y squared. Okay, and in part B, we need to find the PDF of y. In part A, it is given the PDF of x, and now we need to find the PDF of y. So how to find the PDF of y from the PDF of x? We actually have to first find the CDF of x, and then change the variable to the CDF of y, and then change it back to a PDF of y. So for the first step, how can we change our PDF to a CDF? We can use integration. We simply integrate our PDF. We can find the CDF. So let's try. For x that fall into negative 0 to a negative infinite to 0, which is something before here. So before here, okay, so we have our CDF equals to 0, because when we need to integrate the otherwise part, which is 0, and then dx, which lead to the result of 0. So we can simply write it as 0. For x that fall into this domain, we have 0 to 1, but not included 1. And then our CDF is equals to what we have above. We have 0 plus, we integrate from 0 to x, and then our fx is 3/16, and then bracket 2 minus square root of x. So again, we can write our constant out here, and then 2 minus square root of x here. Okay, so this time we have 3/16, and then 2x minus x. Here we have 0.5 plus 1, so we have 1.5 and 1.5 integrated from 0 to x. So here we have 3/16, and then we can substitute our x first, so nothing changed. Okay, and then minus 2 times 0 plus 0 to the power of 1.5 right here. So they're just 0, so you don't have to write them. And then we can make it look better. So we have 2/3 and then 1/5 here. So you can find that both of them have a 2. So just here, we will have the result as x, 3/x, and then x minus 1/3 times x to the power of 1/1.5. And that's it for the domain of 0 to 1. For the domain that falls into for x 1 to 9 included, we have our CDF that equals to, again, we have to copy the last part, right? We have our fx or fa before our integration. So in the first part, we have our 0 copied, and this time we have these things copy here. So we have 3/x, and then x minus 1/3 times x to the power of 1.5 plus our integration. So wait, we need to put our 1, substitute our 1 to here, x equals to 1. So we have 1 here, and then put a bracketed 1 here, and 1 to x. And for our fx, we can copy 3/16 times 1 over square root of x, and then dx right here. Okay, so you can use your calculator. You may find that is 1 minus 1/3 is actually equals to 2/3, and then you can times 3/x. So this part we have 1/4 plus 3/16, and here we have x to the power of negative 0.5, right? So when we integrate it, we have 2 plus 1. So now we will have x to the power of 0.5 over 0.5, and then here we have x and 1. So we can substitute the x first. So we may have x 0.5 minus 1, then 0.5 and 0.5, like this. Okay, so we have 1 over 0.5, which is equals to 2. So we can just change it back to 2x 0.5 minus 2. Okay, so here what we left is just some basic calculation. We have 3 over x 0.5 here, and then 3 over x. So 1 over 4 minus 3 over x is equals to negative 1 over x, and then here we have 3 over x 0.5. Okay, so the last part we have for x that falls into we have the negative infinite, so of course we will end with a positive infinite. So here we will have 9 to the positive infinite. We will have again we copy that of what we've calculate. First we have 3 over x, and then here we have our 9, 0.5 minus 1 over x. We just copy our 9, substitute it back to our x. Okay, and then we have plus integration. So for values that are greater than 9, we actually falls into the otherwise part. So we integrate 0, which gives us 0. So you can just remove this part and use your calculator. 3 over x times square root of 9, which is 3, and then minus 1 over x, you have 1. So it makes sense every time that for your last step you will have a 1 as your answer, because here we have one concept point. The total area of our PDF is always 1. So for here we'll always end with a 1. So now we can write a summary that our CDF of x is actually equals to the first part we have 0, the second part we have here, the third one, and the last one right here. Okay, so we have 0 when we have our x smaller than 0. We have 3 over x times x minus 1 over 3, x to the 1 over x to the 1.5 power, and then when our x is greater than or equals to 0 and smaller than 1, and then we will have 3 over x and x 0.5 here minus 1 over x. Again we fall into the domain of 1, and then here we have 9, and the last part we have 1 when x is greater than 9. Okay, so here we find the fx, the CDF of x, and then we can change our variable from x to y using here the relationship x is equals to y squared. So we can just change the variable. You can just copy everything and then change the variable like this. Right here we have y squared, here we have y squared, y squared, y squared, again everything just the same, y squared. Okay, so now we can make it look clear that now we have our gy. So our gy, our gy is equals to 0, and then y smaller than 0, and here we have 3 over x y squared minus 1 over 3 y. We have 1.5 times 2, so it is 3, and then which we have 0, and then y, and then 1. For here we again have y cube minus 1 over x. Oh, it's 0.5, so it's actually 1, so we don't have to write anything up here. And then we have 1 y, and then we have 3, because look at these parts, we need to give our square to here, which make it as a square root of 9, so we have a 3 as our answer, and here we have 1, and then the same, we have 3 right here. Okay, so here we finish our CDF of y, which is we write it as a g, and for the last part, of course, we can change it as gy. So for our gy, we need to do differentiation, because look at here. We need to do integration of PDF to find our CDF. So of course, for our reverse operation, we need to do differentiation. So now we differentiate 0, okay, which give us 0. So we can write our 0 on the last row, and otherwise right here. And then for our second row, we have 3 over x as a constant, so we just copy it. And for y squared, we make it as 2y minus 1 over 3 times 3y squared. And then here we have 0, y, and 1. Okay, for the third row, we have 1 as our index. So when we integrate it, it becomes just a constant 1, and then minus 0. Again, we can copy our domain 1 to 3 right here. And for our last row, again, it is a constant, so when we differentiate a constant, it's equals to 0, and we can put it right here. So our final solution will be 3 over x 2y minus y squared, and then here we have 0 to 1, and then here we have 3 over x only, and the domain is 1 to 3. And then for the last row, we have 0 when we point to the domain of otherwise. And here is the solution of our part B PDF of y. So it looks pretty long and complex, but is actually pretty simple. Okay, what you are doing is first integration, and then change your variable, and then differentiation, dy dx. Okay, so 3 steps only. So for here, the integration part, I expand all the steps, which makes the step pretty long, pretty complex. But of course, you may remove some of the steps just to make your the length of your answer shorter to fit in one page. But it doesn't really matters for you, because during your exam you can have extra paper, like additional papers if you want, and you may ask your examiner to help you to do so.